Hi, and welcome to this session where I'm going to spend some time to talk about how to tackle digital infrastructure complexity with intelligent and automated observability. My name is Spitzbart. I'm the Vice President for Sales Engineering at Europe, Middle East, and Africa for Dynatrace. And I'm going to spend the next 10 minutes or so to give you a little bit more insights into this topic. Now, I'm not going to give you any new information if I say that every business is undergoing a digital transformation. And also not if I say that, of course, the pandemic that has hit us all over the last 18 months has only accelerated the need for applications, infrastructure to work perfectly every single time. Now, if I look at our customer base, the organizations that I work with, one thing has become pretty clear, that this digital transformation is going to happen on a multi-clouded platform. And what I mean by that is the combination of on-premises infrastructure that organizations very often already have, of new cloud platforms like Microsoft with their Azure or Amazon with the AWS platform, and also container platforms often built on or around Kubernetes, whether it's OpenShift as an on-premise offering by Red Hat, or whether it's the various managed services like Google, Azure, and AWS all offering their own Kubernetes flavors for doing that. Now, when we think about these dynamic multi-clouds, why is the complexity getting worse and worse if you are moving into those cloud platforms? Now, the first aspect is that everything is dynamic. Everything is being spread and stored inside containers. So we suddenly have a lot of very small pieces that all interact with each other and that all are dynamically spun up, spun down, multiple instances running, and all together are responsible for our applications to work. And that's a complexity, that's a scale that we haven't seen in the old data center world that we all used to live in. The second aspect is the volume of data, the variety, but also the velocity has increased dramatically. And it's beyond, if you think about monitoring, if you think about keeping track of this platform, it's beyond what you can visualize and really follow on dashboards alone. The third aspect is the frequency of change. Think of today's world where applications are not just updated once a year, every 6 months, or maybe once a quarter. Very often development cycles are now 2 weeks in duration. Every 2 weeks, new releases get deployed into production. And new releases mean change. New releases mean that your application, how it behaves, how it works, how it interacts, has fundamentally a chance of being changed every single time you deploy. And 2 weeks is, for a lot of our customers, already pretty slow. Some of them are deploying daily, multiple times a day, and they need to think about how to tackle this complexity and also this very fluent environment when we talk about observability, when we talk about monitoring. The third aspect is that applications have become more and more important, and they're more important than ever. As you are actually attending this event here, we are all depending on software and applications to work perfectly, both to record my video, to stream my slides, bring it all together synchronized with the audio track that I'm providing. So we are all depending on applications. And if you think throughout your daily life, just think how many applications it takes for all the daily tasks that you are doing to work. From the groceries you're buying, from the flights that you are taking, assuming the pandemic allows us to do so, from the banking that is now done mostly through mobile or through applications as well. And the fifth and last point is that the resources are getting more and more limited. I have yet to find an organization that tells me, yeah, no problem, we'll just get more resources for our operations team. That's not an issue. We are increasing our footprint there. No, most of the times, at best, it is staying stable while doing more. Very often, it's a combination of being asked to do more, while at the same time having less and less resources available for doing something. Now, with those 5 things in mind, how complexity changes, if we try to put that a little bit more on a time scale, we are hitting what I try to call here the cloud complexity wall. Now, if you think about the early days, it was about individual applications that we brought into the cloud. It was very often early adopter teams. It was the, I would say, either less important application or the single applications that were very much isolated and could easily be either lifted or shifted or re-architected for the cloud. The second phase in the middle here, what I try to call here the early cloud platform, is the one where it's multiple applications, but it's still very much focused on one single cloud platform. First movements into a cloud native development, so taking advantage of all the good things that cloud platforms bring us. And it then starts to get into the area where we are starting to accelerate both the deployment speed, but also the expectations we have at those platforms. And as we really shift over from this single cloud approach now to multiple clouds, now all those environments need to work together. All the while we are shifting applications, we are re-architecting them, and we're trying to move from a still sometimes static world with virtualization or virtual machines to a very dynamic world now with containers, container platforms, and orchestration layers. That's when a lot of customers that I deal with are really getting to struggle. They're struggling with, how do I deal with this complexity? Now, before I jump into how to deal with this complexity, I also want to clarify two terms that I've already used throughout the first couple of minutes of this presentation, but I at least want to give you my definition or what I mean by those terms. Now, when I refer to monitoring, what I refer to is the classical approach of how applications infrastructure were monitored or were actually looked after. A collection of individual tools, very often the best of breed tools. You had your infrastructure tool, the network monitoring tool, maybe now a cloud monitoring tool, one for the application. Maybe you already have an AIOps tool on top that tries to pull all this data together to make more sense. Now, observability comes with a very simplistic approach by saying there's only three types of data that are relevant. There's metrics, numbers that you could put on a chart, for example. There's log files. We all know log files. I mean, for decades, application developers have used log files for storing their data or storing important information about their applications. And there is number three, traces. Traces basically meaning you follow individual transactions through either many layers of your infrastructure, but at least individual components. Very often referred to as cloud ready. There is open source, there's standards around observability. So let's take a look at how could you now tackle, how could you approach this complexity wall that I tried to describe before. Now, option number one is you could continue with the tools you already have by just adding maybe an additional tool or two for keeping the status quo alive per se. So the second approach is what I'd call the do-it-yourself approach, meaning you pick different tools. There's open source solutions out there, maybe some of them that you already have on premise. And you put together such a platform by putting all those things together. Or the third option is to leverage a platform, an observability platform that you purchase out on the market from a vendor that specializes on that. Now, I think we can all agree that the first option is not really an option. So let's dive deeper into do-it-yourself and leveraging a platform. Now, do-it-yourself multi-tool approach on first glance sounds like a very good approach because it's going to be bespoke. It's going to be exactly what you require for your applications, for your infrastructure. But think about the different building blocks that are lined out here. How do you gather the data? Where do you store it? How do you organize it? How do you filter out the noise or suppress the noise? How do you build dashboarding, reporting? And last but not least, how do you all do that at a scale that matches your infrastructure, your application, and your world, your organization? It's going to require your best talent. It's going to steal time from innovation. It's not going to be scalable over time. The third option, to just give you an idea of what are some of the things to think of when you are thinking about such an observability platform. It needs to gather data automatically. Can't be a manual approach, can't be something where you spend time on. It needs to have a built-in repository, how to store data, and organize it automatically for you, not depend on a human to put sense to the data. Noise suppression, AI, needs to be included in such a platform from the beginning, as needs to be a UI dashboarding, reporting, so you can actually leverage this data. and it needs to be scalable. It needs to scale to your environments, whether that's hundreds of servers, thousands, or 10,000s of servers without additional effort. So as you evaluate market options, as you evaluate observability platforms that are out there, think about those different dimensions and how platforms, or maybe your do-it-yourself approach, would measure up against those approaches. And last but not least, when we talk about observability, and you'll hear a lot of vendors telling you that observability is really all you need, I would challenge you to think a little bit beyond. Think about topology, behavior, method level insight, and metadata about which applications are running. All that should be part of an observability platform. Even though observability per se are the top 3 boxes here, there's a lot more that is required from that. Thank you very much for listening. As said, I'm Roman Spitzbart. I work for Dynatrace. Thank you very much.